how you guys did on identifying who is D, who is A, who is B, who is C over B. Did you guys find in your notes what type or what formula I was talking about? Or you knew which one I was talking about? I'm talking about a transformed sinusoid, or sinusoidal, right? I would rewrite this as y equals 0 plus 1 sine of 1/2 x minus, how'd you do? There was no addition in the front, so D is 0. The sine has no number multiplied in front, so it's an understood 1. The x is being divided by 2, which could be rewritten as 1/2 x, because x over 2 is the same thing as the quantity 1/2 times x. So my b was what was my b was the coefficient to the x term. And then is there any addition or subtraction? No, so my c over b is 0. I saw a hand. Jordan.
Oh, no.
You're pondering? Tyler.
I had a question for somebody else.
Does the 1/2 kind of make sense?
The 1/2 makes sense, but I don't get how you got
C over b, well, think of it this way. The d is what's being added in front, nothing. And the c over b is what's being added to the x after the 1/2 gets taken out. But there's nothing being added to the x, so I can just make it a 0 with or without the 1/2. Does that make sense? And you can always check if I was to multiply, that would be this, and that would go away. So it's okay. Now, why did I have you identify all that? Because what did we learn yesterday? Go ahead, open up a notes if you don't already have them open. I want you to look at the example we did yesterday, but also the numbering of the transformed sinusoid as sinusoid. Oh my goodness. Never said it that way before. As far as what order we go in when we graph. Because didn't I put an order as to what to do when? Right? So I want you guys to grab that out. Be looking at that. Who is D? Who is A? Who is B? Who is C over B? What should I do first? Check out my, sinusoidal axis, otherwise known as D, right? So that's the center of that handwriting line, or of my wave, the equilibrium. Didn't go anywhere, so it's going to still be the axis. How high, how low does my wave go? Goes one up and one down, right? So I can go ahead and mark one up and one down. Now, if you were to graph this on your graphing calculator, is this a really tall wave, like an in-between wave, or a really small wave? Yeah, because if you were to graph it on your calculator, wouldn't it be like a 10 by 10 screen? How big is 1? And then really it's 1 up, 1 down, so it's really a total height of 2. Yeah, it's going to be baby. I just want you guys to remember in context, I'm making the 1 big up here, but in your graphing window, it'll be way down there. Okay. Then I made my top boundary for my wave, my bottom boundary for my wave. And remember, I'm keeping everything dotted because this isn't technically the wave itself. It's just the guidelines. Now, after we do the amplitude, we've done the D, we've done the A. Do we do B next, or do we go to B next? No. Check out your ordering. You might want to order it. You do 1, then 2, then 3. This guy has to go to the period, and that's kind of tricky. So we're going to go there, but not yet. We're going to skip him for a second. This one, C over B, is used for our initial point. Now the nice thing is we can totally use that x value of 0. We have to figure out the y value. Who is this, a sine or cosine? And looking at your notes, no one answer, pause, look at your notes. Does sine start in the middle or at the top? Wait, don't answer. Look and see, does sine start in the middle or at the top? Okay, who has an answer for me? Matthew, where does it start? It starts in the middle. So if it starts in the middle, who is the middle again? 0. So my initial point is going to be 0, 0. Sweet. Do you remember the dilemma, though? Is it going to be like this? Is it going to be like this? Is it going to be like this? What do we still need to find? We know how tall, we know how high it goes, we know how low it goes, we know where it starts, but what don't we know yet? We actually know the amplitude. That's the how high, how low. The period. And what is the period? Try to describe it. Yeah. There's a formula for it, but what did you just see me changing? How long it is. That's the easy way of remembering it. Just how long it is, right? How far from beginning to end of one cycle. The horizontal stretch or compression. So, Jordan, I think you said 2 pi over b, right? Oh, that's awkward. What's another way of thinking about it? 1 over b, or the reciprocal times 2 pi. So I could do 2 pi times 2. Does that make sense? If I divide by 1/2 and multiply by 2. So what's my period? Now remember, we didn't just want the period. We also wanted to cut it into fourths because of all of the special points we have to fit in. We want to know what units to make it. So what would a quarter of the period be? What are we going by? Pi's. Why is that nice? Because I'm just going to go ahead and mark it. From 0, add pi, add pi, add pi, add pi. And then remember, we're just going to do our key points. So we have it's a sign starting in the middle. Where do we go? Yeah. Top, middle, bottom, middle. And we made the units exactly what we needed them to be. Now 4 pi in context, remember he's about 12-ish, he's a little bit more, but he's 12 something. So you might not be able to see this whole thing if you were just to graph it in Zoom standard, but it'd be really, really short, it'd be really, really small as far as vertically, but horizontally it's going to take quite a long time to complete. And then if they said something like in homework, help me out if they said this, didn't they talk about like showing 2 cycles or something like that? What they mean is keep going. And you could keep going this way, 5 pi, 6 pi, 7 pi, 8 pi, to get another cycle. Or you could do what? Yeah, negative pi, negative 2 pi, negative 3 pi, negative 4 pi, and just go the other direction. So if the wave continues, it's not going to bounce up. That just isn't what a wave does. What's it going to do? Yeah, it's going to keep, sure. It's going to keep with the same motion, right? It's going to be nice fluid motion. There you go. There's 2 cycles. Dun, 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 dun. Oh. Dun, dun. Jordan.
Okay. I have some questions.
Go ahead.
So first, how did you get the initial point?
2 things. One was using c over b as my x.
And which, because there's like 2 equations that you use, right?
Uh-huh.
How do you know which one to use?
Which guy you have. So if you look, sine is the one that has c over b with the middle. And the middle is the same thing as d. I think that's the formula I gave you. Oh, yeah. So let me go back really quickly so you can see that, if it lets me go back. It would have been this page, I think. So sine starts in the middle. Cosine starts in the top. Except, what was that weird example yesterday where we didn't start at the top, we started at the bottom? Do you remember why? There was the reflection, and how did we see that in the equation? Where did that come in? Yeah, there was a minus instead of a plus. So there was the vertical flip. So the one time it changes, cosine started at the bottom because there was the vertical flip. And it started technically over here at -2. Now we were lucky. We started it here at 0. And just because of how everything played out, if we had kept on going, it would have started in the right place. But that was really dangerous. We actually made a mistake yesterday in not starting way over here at -2. We started at 0, went backwards, and we're like, whew, okay. -2 is okay. It would have been the initial point, and it ended up going through the point that we had originally put. But cosine starts at the top unless it's been flipped. Then cosine starts at the bottom. Sine starts in the middle. Wait, why would sine start in the middle either way, whether or not it was reflected? Yeah, and the middle flipped is still the middle. Yeah. But if sine got reflected, let's go back to the sine curve that we just did. If sine got reflected, instead of going up, what would the sine curve do? It would go down. So it would still start at the same place, always in the middle. At the top, unless it's been, then it starts at the bottom. What's what? Oh, the sinusoidal axis. Yeah, sinusoidal axis. Because it's the axis about which the sinusoid revolves. Now, the next one's going to be a little bit less hard. In my head, it's a little less hard, but in some ways, it's actually a little bit harder. So the next problem that we have has way more transformations. This one only had a horizontal stretch by a factor of 2. Do you guys see it? The only thing that was going on was a horizontal on the inside multiplication, dilation, stretch or compress by a factor of, remember, different than what I think, by a factor of 2. So instead of going to 2 pi, it went to 4 pi. But otherwise, it went up as high and down as low as it normally goes. It started in the middle like it normally does, and this didn't get shifted. So this was actually a super basic graph with one transformation. It was just hard to figure out who all of your different guys were. This guy has way more transformations, except, oh, hey, look, the D is really easy. The A is really easy. Can we rewrite him? What do you guys think? Let's go to our notes, because now this is a bit more complicated. Even though in some ways it's easier, because you don't have to, like, make your different letters 0. In some ways it's easier, because you can see the D, see the A. In some ways it's a little bit harder, because there's a lot of stuff going on. But as long as we follow our process, we'll be all right. Except he gets a little hard right around here. You guys see it? We need to figure out who's B and who's C over B. So let's rewrite him. The beginning's easy. There's my D. There's my A. It's a plus, so no weird reflection. It's a cosine, so it's going to start at the top. Who's my B and who's my C over B? Can we start with C over B? Is he the easier one? Is there anything getting added or subtracted on the inside? No. So even though there's something being multiplied, what can I still put as this guy?
0.
Yeah. So if there's no addition or subtraction, then put 0, just like we did with the D a second ago and with the C over B a second ago. But based on the last example, can you guys tell what we're going to pull out for B? Not just over 12. What else? Yeah. Does that make sense? Pi's a number, 12's a number, so they're both the coefficients. So now that we've done one all together, I want you guys to get just a step or two ahead of me. I'm going to slowly bring up the rear, but go in the same order that we just went. Graph your sinusoidal axis first. But it's not at 0 this time. Graph the upper boundary and the lower boundary of the wave using the amplitude next. Try to identify your initial point either with the formula from your notes or the idea of cosine starts at the top. And if you're really acing this, then try to think about how long it will take for a cycle using the period and the units you should go using the quarter cycles. I'm going to slowly bring up the rear. Some of you might just want to wait and do it with me, and that's okay. But some of you are like, no, I think I can get at least a little bit ahead. I'm going to start in about 30 seconds. you guys did the first 2 steps, you can check them now. As far as where the sinusoidal axis should be, the whole thing was shifted down 3. How high, how low it should go, up 5, down 5. Why is my initial point 0.02? Good, good. C over B is 0. And I think, Joe, you were saying it, cosine starts at the top, and who is the top of my boundary? 2, which is negative 3 plus 5. Yeah.
I guess I didn't write this down. Like for the sine, for the equation for the initial point C over B, D.
Yeah.
What is it for cosine?
C over B, D plus A. Because middle plus amplitude. Does that make sense?
Yeah.
Will get you to the top. Now what's the struggle? Do you remember the very last thing we need to do? It's kind of 2 things in one. Figure out how long. Yeah. How long. We already know how low it goes, just how long until it completes. To make it really narrow, to make it really wide, and what are my tick marks? And so as I think, Joe, you just said it, period is where we're going next. Using that B. We can't just say the period is B. Sadly, no. This is the factor. Well, it's the reciprocal of the factor for 2 pi. So you could write 2 pi over 12. But what would be an easier way of thinking about it? 2 pi times reciprocal, 12 over pi. Horizontal dilation is always the reciprocal. Pi's cancel. That's cool. 2 and 12 makes 24. Do I want to go by ones this time? No. Do I want to go by 2 pi's or single pi's? No. What do I want to go by? 6. Because think about quarter cycles. What's 24 cut into fourths? Let's go by 6s. So 0 plus 6, plus 6, plus 6, plus 6. Now pause. What if, now this is going to take a little bit of mental effort, so hold on. Don't write this. I'm changing the color. I'm changing the problem for just 1 second. Which this would have to be different also, but for right now, what if this was something like 2? I know it's hard. That means that it would have been shifted right 2. So you would have the point 2, 2. How would you go by 6s from 2? You could go 2, have 2 be short, and then you would have to be at 8, and then you'd have to be at right. So you could go, or you could just go by 2s, because won't the 2s help you with 6s also? So when you have some sort of horizontal shift, it might not be the nice, pretty 6, 12, 18, 24. It might be from 2, 6, which is 8, and from 8, another 6, which is 14, and from 14, another 6. So you just have to be careful. When you go by 6s, if you start at 0, it's nice and pretty. If you have to start somewhere else, you're going to have to make maybe some adjustments to how you do it, because it's not going to be the nice 6, 12, 18, 24. But we don't have to worry about that in this problem. We didn't have a horizontal shift. So we got to start at 0, and 0 plus 6 is just 6 plus 6 plus 6 plus 6. What was the point of cutting it into fourths again? How many key points are there to any wave? 5. So where do I go from the top? I go over 6, and I go to the middle. Does that make sense? Not this middle, the sinusoidal axis middle, the wave's middle. If you want to think about it, we could think that like, hey, the water level was, but it's been a drought, so now the water level is. You can think of something like that. Yeah, Jordan.
So how did you, I thought like from the 2 you would go like down 5 and up 5.
Yeah. So I go down 5, and then I'm going to go down another 5.
Wait, why is it like that? Why is it not like 5? Like why'd you go down 5?
Oh, cosine's the top already.
So negative 3 is the middle? Okay.
So if you want to think about your pendulum example, I think, Salma, you're the one that remembered we did this. The pendulum example, sine would start in the middle, and so you would push the pendulum. And so the beginning of the motion would be in the middle, and then it would go to the maximum, minimum, and then back to the middle. Cosine is you hold the pendulum over here, and you let it go. So it starts at the top, and then it goes backwards, and then it comes.
So cosine is always going to go like down. Why is that with the
Right. Well, go down and then back up. Unless it's been flipped, then it's going up and then back down. But it's the same kind of motion. What if you need 2 cycles? Could you go all the way to 48? Sure. Or you could also go to negative 24. And I'm just doing that because I'm pretty sure a lot of the ones in the book you guys are graphing say 2 cycles. But here's a place that's really easy to get confused, and I sometimes do it just today. I guess I was a little bit more alert, had my coffee this morning. It's really easy, especially if the shift is very slight. It's very easy to put your middle on the x-axis because you're so used to it. Make sure you're going to the sinusoidal axis. Once again, like my example, the water might have been here at one point, but there's been some evaporation due to drought. Now it's down here. The wave isn't going to cycle around the old place. It's going to cycle around where the water currently is. And that's just an example as to why there might be a shift down. If you're dealing with water, there you go. Okay. Now, in homework, sadly, you didn't just have equations getting sinusoids. Not that those are super, super easy, and as you guys can tell, I apologize. Being tall and then trying to like do straight lines way down here is kind of, it's supposed to be straight across. But anyway, long story short. The examples in the book aren't just this guy going to this guy, equations going to graphs. What if you're supposed to go backwards? And here's why I didn't want you to be forced to try all of homework, because some of you didn't even have the graphing down, let alone going backwards. So let's work together as a class to try to fill in. Wait a minute. This could be a sine curve. Could be. That's what I'm saying. It could be a sine curve, or it could be a cosine curve. Right? It could be a sine curve or a cosine curve. But why are we going to make it a cosine? Maybe it's the closest, or if they tell you. So if they don't tell you who to do, you could do a sine or a cosine depending on the clues. But then this one, since it said cosine, okay, fine, I'll do cosine. And I'm going to start with, ooh, not that color. I'm going to start with what I want to fill in. That sounds like a smart idea, right? Get it ready to go. So who has something I can fill in? D. D. There's no vertical shift, so D is going to be. Now, how do you know that for sure? It looks like it. Oh. How high does it go? How low does it go? What's in the middle? That's the way to know for sure 0. Otherwise, it looks like 0. For sure it's 0 because it goes up to 2, down to 2. The middle is 0. Does that make sense? And since we were figuring out up 2, down 2, what else can I fill in?
Amplitude.
Got it. Now I put a plus, which means I'm looking for a top of a wave. To start the cosine, I'm looking at a top. Could I have made this a minus and I would look for the bottom instead? Yeah. It'd still be cosine. I could look for the top and make it a plus, or I could look for the bottom and make it a minus. Is it okay if we just do plus? Is that fine? Cool. Has there been a shift, yes or no? Yes. Because if it didn't shift, where would it be? On the axis itself, but there's been a shift. Looks like halfway, but how did Joe come up with pi over 4 so fast? Oh, that's pi. What would this one be? And what's a half of pi over 2? Oh, that makes sense. Good job, Joe. So pi over 4. I'm almost done. Why is it a minus pi over 4? Because I shifted to the, and it's always backwards what we think, right? Who's missing? And where do we get B? Oh, he's right. No, he's not. Where do we get B? I need to figure out who the period is so I can solve for B. Is it 2 pi? How do we know for sure? We have to look at the beginning and end of something, right? Now, do we even have the end of this guy to even look at? Could I look at the distance from here to here and it should be the exact same? Because that would be a full cycle. I mean, I know I'm not doing that graph. I'm doing a plus cosine starting there, but I can look at the distance and figure it out. How is that helpful? Well, guys, isn't that pi? What would this one be? Yeah. So pi left and pi right, then what's my period? Oh, it didn't change. Since it didn't change, what does that mean B is? B is just 1. Because there was no stretch or compression. So the period just stayed the same. Joe, what's up? Well, I'm taking, oh, I see. Sorry, I was looking at it from the side. Well, yeah. This tick mark is negative pi, right? But what Joe's pointing out, sorry, from your guys' perspective, it's much more accurate than mine. Technically, this would have been negative 3 pi over 2, because it's technically hitting halfway in between. And this one's technically hitting halfway in between, but what's the nice thing? Oops, sorry. If you have, no, that's not 3 pi over 2, my bad. It's a little bit less than pi. That would be 3 pi over 4, right? Because we have 1/4, 1/2, 3/4, 1 whole. My bad. And then we have 1/4, 1/2, 3/4, 1 whole. 5 pi over 4. Do you guys see how it's still, if every tick mark is a half pi, 1/2 pi, 1 whole pi, 1.5 pi, 2 whole pi. We were right with the 2 pi distance. It was just, we weren't perfectly right as to where that was hitting. Now, if worse comes to worse, you're like, I don't know what that distance is. I don't want to go counting stuff. Well, you could go ahead and do 5 pi over 4 minus negative 3 pi over 4. You could find the distance by subtracting the 2. Subtracting a negative is adding. What's 8 pi over 4? 2 pi. So either way, it is 2 pi. Thank you, Joe. When I look at the side, it's a little bit skewed. But it's still 2 pi. So the B is still 1. So what's our final answer? 2 cosine. How could you get your graphing calculator to make this for you? To double check that you're right, because there might be a few places in homework where you want to do that before we grade it tomorrow. Graph it, but you would want to be in radian mode. How do I know that? You're going by pi's, not by angles, and not by degrees. So you'd want to be in radian mode. Besides that, I don't think there's anything else too crazy besides what zoom you want to be in. But guys, would you see this in zoom standard? Does it fit within a negative 10, 10, negative 10, 10? Yeah, but what's it going to be? It's going to be small, but that's okay. That's okay. You should be able to compare. So that's going from a graph to an equation. What if they give you words? Wait, is it possible to do a sine curve in terms of cosine? Yes. No. I know. You were just trusting that what I wrote was actually right. That was for an old problem. There we go. If they tell you use a sine curve, then use a sine curve. Now, if they say sinusoidal, you get to choose, but sine means sine. So, you guys, probably this is actually easier than the last one. Is this one easier than the last one? What do you already see you can plug in? Amplitude of 2. Don't go plugging in the period. Remember, that one's tricky. But amplitude of 2, that one's easy. What else? Phase shift. Where does that go? Subtraction on the, oops, sorry, not 2. What is it, pi over 2? What else? D is 1. Translation up 1, just a positive 1. Who am I missing? How do I find him? Pi needs to come from 2 pi over b. Does that make sense? And so, yeah, you can think of what would I need to divide by, or if some of you need to actually do the math, multiply by b, divide by pi. But some of you, most of you have already gotten to b is equal to 2. Dun, 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 dun. So either equation to graph, graph to equation, words to equation. That's the majority of homework. Finish up for tomorrow so we can grade the evens, yeah? We can go over questions of what you had, but hopefully, let's ignore that. And if we get to a word problem, you might have one in homework. We'll deal with it then. He's alive. Thanks, bud. So what's the key summary? If you can get a sine or a cosine written in this transform form, should you guys hopefully be able to, wherever it is, mark the D. Wherever that is, look at the A and be able to add A or subtract A to get to the top or the bottom bounds. To use the C over B and whoever you have to make your initial point, with the C over B and, well, you're going to have to figure out middle or top or bottom, right? And once you do have your initial point, let's say it was a sine, let's say it's in the middle, we're putting it at C over B, wherever that is. The last thing you have to figure out is your, who tells me this part? Who tells me the how long? We use our D, our A, our C over B, our period. And where does our period come from? 2 pi over B. And what do I want to do with that 2 pi over B, which tells me beginning to end? I also want to figure out my quarter cycles to be able to do each of my key points to get my wave. Does that make sense? Okay. That's how to take any problem we're given, rewrite it so that we can use our clues to get our waves. Dun, 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 dun. So, where are we going in section 4? That was weird. 6 tomorrow. Where are we going in section 4, 6 tomorrow? Tangents and cotangents. Well, you know what? I'm actually going to switch up the order to this just a little bit. I'm going to switch up the order in section 4, 6. And instead of going to tangents and cotangents, we're going to do this backwards. And we're going to actually go to cosecants and secants first instead tomorrow. And here's why. You guys know who cosecant is, don't you? Isn't he 1 over sine? And you know who secant is, right? Isn't he the reciprocal of cosine, which is not second sine in your calculator, and it's not second cosine in your calculator. Those are different. But 1 over 1 divided by 1 over 1 divided by. Who do you see in between the cosecant graphs? And who do you see in between the secant graphs?
The point of sine.
I see a sine, and I see a cosine. So guess what we're going to do to graph cosecant and secant? Not in this class. You might have done it in Algebra 2. Oh, that's kind of cool. Yeah, we haven't even talked about it this year. Unless you walked in like an honors lesson, like you might have seen it up on the board. I don't remember. It probably was Algebra 2 then. But all we need to do is get the sine or the cosine. Not even worrying about the 1 over. Get the sine, get the cosine, get the sine curve using all the skills you're doing in 4, 5. Or get the cosine curve using all the skills, which can be moved, which can be stretched, The amplitude can change, the phase shift can change, all that jazz, the period can change. But if we can get the sine, if we can get the cosine, all we have to do for secant or cosecant is bounce off. Now, we have some vertical asymptotes that happen at the intercepts with the sinusoid. But then otherwise, we bounce, 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 and we're done. So if you were to have to graph something like, where's a good one? Let's go back. If you were to have to graph something like this one, which we'll see tomorrow, you're not going to graph him. Guess who you're going to graph? Who's cosecant the reciprocal of? Oh my goodness. So it's really like section 4.5? Yeah, we're going to graph this first. But instead of making it solid, we're going to make it dotted. And then we're going to go ahead and bouncity, bounce, bounce, bounce.
Then you just like slice it on the sinusoidal axis and pull the killer like that.
That's one way of thinking about it. Joe's saying think about the sine curve and think about it as being like an actual solid, and you slice and then you just peel and you peel. I kind of like the bouncity bounce bounce better, but okay, either way. So what do you need to do to be able to do cosecants and secants? Sines and cosines. What are you going to finish up tonight? Sines and cosines of section 4.5. Sound good? All right, and then come in tomorrow ready to do bouncity bounce bounce and say, well, who on earth is tangent and cotangent then? Well, they're a little bit different. They're a little bit unique. We'll see them tomorrow. Bye, guys. Get out of here.